Enhancing an image of a scanned document. You probably do it yourself every now and then when you use your favorite document scanning app on your smartphone to scan a document. In this video, we want to replicate this effect. We want to get from this image to this one. It's just nicer to read and easier to print since it has a white background. So, how do you do it? The keyword here is thresholding. Or to be more precise, binary thresholding, adaptive thresholding, or Otsu's method. If you want to know what the differences are and how we get to the result I just showed, just tag along. We are going to use Python and OpenCV to do exactly that. I will show you some code examples so you can replicate that at home or integrate it in your app. Alright, let's not waste any more time and get straight to the code. Let's have a look at binary thresholding. In this example, I'm loading an image and convert it into grayscale. Next, I set the threshold. Every pixel in the image that has a brightness value of less than the threshold will be black in the output image. Every pixel that has a brightness value of the threshold or greater will be white in the output image. So, how would you implement this? First, you want to load OpenCV and NumPy. Then, you want to load the image from disk and convert it into grayscale. Next, you pass that grayscale image to the OpenCV threshold function as a first argument. Then, you define the threshold. Next, you define the value which each pixel should be assigned if it exceeds or is equal to the threshold. Otherwise, the pixel value in the output image will be 0. As last argument, you define the exact thresholding method. We will keep this at binary thresholding. There are more methods available. If you want to know about them, have a look at the official OpenCV documentation. Binary thresholding is very simple and effective and easy to implement. However, it has some drawbacks. The first and most obvious drawback is that you have to set the threshold in a manual fashion. Second, especially in this example, if I set the threshold too low, then the letters kinda thin out, and even worse, if I set the threshold too high, then the shadow of the smartphone will be rendered as black and the image enhancement fails. Let's move to adaptive thresholding. Here we can vary two parameters, namely block size and constant C. If we choose them correctly, we are able to separate the background in the shadowy area as well as in the well-lit area. So what's maybe a little bit hard is to understand how this constant C works. On the right side you see, if you set it too small, then you will get artifacts. So why is that? So for this we may have a look at how this windowing or this neighborhood of adaptive thresholding actually works. I have some zoomed area here and here of the image with the brightness value of the center pixel written to its right. Around the pixel we have a 5 by 5 neighborhood which is defined by the block size. So in addition to the center pixel value, we have the average brightness of the 5 by 5 neighborhood. We can acquire this average brightness by taking the mean of all those pixels or by even weighting them by a Gaussian window. In any case, what is happening next is that the center pixel will be compared to its neighborhood. This is why adaptive thresholding works so well in shadowy areas and in well-lit areas, because the only thing it is doing is it is comparing relative brightness values. So if the pixel, for example, has a value of 195 and that is greater than 192, then it will be segmented as background. If the pixel has a brightness value of 194 and the average brightness around the pixel would be 195, then without the C value, that pixel would be classified as foreground and would be painted black. And this is exactly what's happening in the top image. So to circumvent that, we introduce this constant C. So this allows the pixel to be a bit less bright than its surroundings. So if I set C to 2, I allow the pixel basically to be 194 or 193 in this case. So since we have set it to 2, this pixel is good and it will be still classified as background. Another pixel with a value of 190 and the average background of 199, in this case won't be classified as background even though it may be belonging to it. Then what you need to do is increase the constant C. However, don't set the constant too high because at some point everything will be classified as background. In the last scenario, we have a pixel value that is way less bright than its surroundings, so in that case it is correctly classified as foreground and black in the output image. So let's implement this. The adaptive threshold method also expects a grayscale image as input. Next, we set the maximum value assigned if the pixel exceeds the threshold to 255 again. In this case, we tell the method to use a Gaussian window to compute the brightness around the pixel. The output image should be again in the form of binary thresholding. The block size or the window size will be 5 by 5. So we luckily found a way to segment foreground and background based on relative brightness by looking at the neighborhood of each pixel. So this is it? Not quite. If we can assume that the background is uniform, there's a way to automatically find the optimal threshold for binary thresholding. So without going into too much detail, what Otsu's method is basically doing is it looks at the image histogram and then finds the threshold that best separates the distribution between dark and bright spots in the image. In this example, it is 118. The result you can see on the left. Implementing this is again straightforward. We again read an image as grayscale and pass it to the threshold function. We set the threshold value, which in this case doesn't matter since we will use Otsu's thresholding as method. Remember, it finds the threshold automatically. Next, we assign the maximum value for pixels that exceeds the threshold, which we set to 255 again. Then, as a thresholding type, we choose a combination of binary thresholding and Otsu's thresholding. Alright, this is it. I hope it's a bit clearer now what binary thresholding, adaptive thresholding and Otsu's method is. I will put the link to GitHub where you can check out the demo applications I made for this video and also link to an article I wrote about this. And yep, I hope you enjoyed the video. Have a great day. Bye.